Good morning students, I am S. Prakasam. In 12th chemistry, we have already completed 4 lessons. Lesson 1 metallurgy, lesson 2 P black elements 1, lesson 6 solid state, lesson 7 chemical kinetics. Today I am going to start the lesson 3 P black elements 2. In periodic table, 13 to 18 group elements are called P black elements because the outermost electron filled in the p orbital. In P black elements 1, we have learned the first 2 group elements, namely boron group, icosagen group and carbon group, dinitrogen group. In P black elements 2, we are going to learn about the remaining group elements present in P black. 15th group, nitrogen group, it is also called Pnictogen. 16th group, oxygen group, it is also called as chalcogen. 17th group, which is also called as halogen. 18th group, it is also called noble gas or the inert gases. In P black elements 2, first we are going to learn about nitrogen group. Nitrogen group elements also called as Pnictogen. Pnictogen is the word derived from Greek. The Greek word nigein, which means to choke. This refers to the choking property of nitrogen gas. So these group elements collectively called as Pnictogen. This nitrogen group contain nitrogen, phosphorus, arsenic, antimony and bismuth. Occurrence of nitrogen group elements. We know that in our earth crust, which contain 78% of nitrogen present in the form of dinitrogen, N2 gas. We know very well about nitrogen is a diatomic molecule, so it is obtained in the form of dinitrogen gas or N2 gas. It is also present in the earth crust in the form of sodium nitrate. NaNO3 is the chemical formula for sodium nitrate, which is also called as chili saltpeter because it is found in large deposits of chili. So it is also called as chili saltpeter. And potassium nitrate, KNO3, is the chemical formula for potassium nitrate. It is also called as Indian saltpeter. These are the source or occurrence of nitrogen. One is atmospheric air, which contains 78%, or it is present in the earth crust in the form of sodium nitrate or potassium nitrate. The 11th most abundant element in the periodic table is phosphorus, which is also belongs to nitrogen group. This phosphorus exists in the form of phosphate, fluorapatite, chloropatite and hydroxyapatite. The other elements present in the group, arsenic, antimony and bismuth, these are present in the form of sulfides, and these elements are not very abundant in the earth crust. These are the occurrence of nitrogen group elements present in the earth crust. Physical property of the nitrogen group element. First, now we consider the physical state. Except nitrogen, remaining elements are present in the form of solid. Phosphorus, arsenic, antimony and bismuth. These elements are present in the form of solid, but nitrogen only exists in the form of gas at room temperature, that is 293 Kelvin or 25 degrees Celsius. Nitrogen exists in gas. The remaining elements are obtained in the form of solid. Atomic number gradually increases from nitrogen to bismuth. Next one, isotopic form. Now, except nitrogen, remaining elements exhibit only one isotopic form. Nitrogen exists two isotopic form. One is N14, another one is N15. We know very well about that. Isotope is nothing but same atomic number exists, different mass number. Here, nitrogen only exists two isotopic form. The remaining elements exist only one isotopic form. Atomic mass also increases from nitrogen to bismuth. Next one, electronic configuration in nitrogen group elements are consists of the general electronic configuration of ns2 np3. The successive electrons are filled in the next higher energy level that is given in the table. Atomic radius, because of increasing atomic number, atomic radius also gradually increases from nitrogen to bismuth. Density, which is also increases because of the increasing atomic mass or atomic weight, density also increases from nitrogen to bismuth. Melting point and boiling point, this value also increases from nitrogen to bismuth. We already know the general trend in periodic table. These properties are gradually increases from top to bottom of the group. That is the physical properties of nitrogen group elements. Preparation of nitrogen. Nitrogen can be prepared by three methods. First one, industrial preparation, large scale preparation of nitrogen, which can be done by the fractional distillation of liquid air. Liquid air can be distillated using the fractional distillating column. We can get the nitrogen. The diagram explains the fractional distillation of nitrogen. The liquefied air can be passed through the distillator. We can get the pure nitrogen gas from the top of the flask, and the liquid oxygen can be obtained by the bottom of the fractional distillating flask. That is one of the method for the preparation of nitrogen by industrial. Second one, it can be obtained from sodium acide. Thermal decomposition of sodium acide at 573 Kelvin, we can get nitrogen gas. For the chemical reaction, 2Na-N3, that is sodium acide, which is thermally decomposed at 575 Kelvin, which gives 3N2 plus 2Na by the formation of nitrogen gas, which also gives the sodium element. That is second method for the preparation of nitrogen gas. Third method, oxidation of ammonia. Ammonia can be oxidized with the help of bromine water. Bromine water used as an oxidizing agent for this reaction. Chemical reaction, 8NH3 plus 3Br2, which gives 6NH4Br plus N2. 8 moles of ammonia react with 3 moles of bromine, which gives 6 moles of ammonium bromide plus N2 gas. These are the method for the preparation of nitrogen. Physical properties of nitrogen. Terrestrial nitrogen contain 14.5% of N14 and 0.4% of N15. Terrestrial nitrogen, which means nitrogen obtained from the atmospheric air, or it may be obtained from earth crust in the form of sodium nitrate or potassium nitrate. That is collectively called terrestrial nitrogen. From the terrestrial nitrogen, N14, which contain 14.5%, and N15, which contain 0.4%, because nitrogen exists two isotopic form, one is N14 and N15. This N15 used for isotopic labeling purpose. Second property, nitrogen is chemically inert in nature due to the higher value of bond energy. We know very well about that. Nitrogen exists in the form of N2 molecule. It is a diatomic molecule. We can break the bond. It required higher amount of energy, that is 225 calories per mole. That is much amount of energy required for breaking the bond present in the two nitrogen atom. So it is chemically inert in nature. Third point, triple bonded nitrogen. In between the two nitrogen atom, it contains triple bond, which is less reactive compared with the other isoelectronic system. Now I consider C triple bond N, N triple bond C, or C triple bond C. These are the isoelectronic system similar with N triple bond N. There is nothing but nitrogen molecule. Why it is less reactive? In the isoelectronic species, that is readily donating pair of electron to other atom or group. But in case of nitrogen molecule, it is not able to readily donate the electron, so it is less reactive in nature. In addition, nitrogen has the ability to donate electron to the metal to form coordination complex, but it is not more extant in nature. These are the physical properties of nitrogen. Chemical properties of nitrogen. First one, formation of ionic nitride. It reacts with the electropositive metal to form corresponding ionic nitride. For example, first reaction 6Li plus N2 gives 2Li3N. 6 moles of lithium metal react with 1 mole of nitrogen to give 2 moles of lithium nitride. The reaction carried out at normal room temperature. Second reaction 3Ca plus N2 gives red hot condition Ca3N2. 3 moles of calcium react with 1 mole of nitrogen at red hot condition. It gives 1 mole of calcium nitride. Third reaction 2B plus N2 bright red hot condition gives 2Bn. 2 moles of boron react with 1 mole of nitrogen and it gives 2 moles of boron nitride. That is the formation of ionic nitride. Nitrogen combined with electropositive metal to form variety of ionic nitride. Second chemical property, Haber's process for the synthesis of ammonia. 1 by 2 moles of N2 plus 3 by 2 moles of H2 equilibrium reaction gives NH3. That is the synthesis of ammonia. For the reaction, delta HF is equal to minus 46.2 kilojoules per mole. Delta H is nothing but change of enthalpy for the formation reaction. It is a negative value, so the reaction is exothermic in nature. That is one of the important method for the synthesis of ammonia. Third chemical property, reaction with oxygen. Nitrogen does not readily combine with air or then oxygen. It is reactive with oxygen at very high temperature, nearly 3473 Kelvin. It reacts with oxygen to form nitrous oxide. Chemical reaction 2N2 plus O2 gives 2N2O. These are the chemical properties of nitrogen. Uses of nitrogen. First one, nitrogen used for the manufacturing of ammonia. By the Haber's process, we can synthesize ammonia. It can be done with the help of nitrogen. It is also used for the manufacturing of nitric acid by Asphalt process. Another one important method for the preparation of nitric acid with the help of nitrogen. It is also used for the preparation of calcium cyanamide. These compounds are prepared with the help of nitrogen. Second use, liquid nitrogen, which is used for producing low temperature. This liquid nitrogen used in cryosurgery purpose, and it is also used for biological preservation. All of you know that biological preservation is nothing but we can preserve the biological specimen. These are the uses of nitrogen.